Hi, teacher Jerry here. Welcome to the next topic on atomic structure. Shouldn't be very uh, new to many of you all because lower set you have talked about atomic structure. But the big picture, why we learn about atomic structure, is to help us to understand later part when we learn in chemistry. Why the mass, when we deal with mass, why do we only look at certain subatomic structure? When we look at reactions, what is actually happening, right? It just helps us to appreciate. So that is the big picture. So this is just a very small picture of what to help us understand the later part. All right. So let's go into it. Okay. So technically, all right. You can see for yourself the atom structure is all right. It's mainly made on nucleus. Okay, where there's a proton, neutron. So actually, nucleus is the core, right? And then the electrons are orbiting around the nucleus. Okay, so we talk about, so do take note, I thought relative means it's not the real mass or the real charge. When we say proton 1, it doesn't mean that proton is 1 gram. What we are just saying that if proton is 1 milligram, then neutron is 1 milligram. It's about 1 is to 1 because we cannot even see proton, neutron. They can never be 1 gram. Okay, but most important thing is see, we look at the charge. So if we want to look at the charge of a substance, we only just look at electrons and protons. We don't care about the neutrons, right? Because the neutron is no charge, zero. So even you got 1 million neutrons, you multiply by zero, it's still zero. It won't affect the charge. But if you look at the mass, all right, then we look at the neutrons and the protons because the electrons is considered negligible. It's only 1 over 1840. If you press a calculator, it's a very, very small value. All right. So that is why later part will help you understand why when we look at mass or when we look at the charge of ions, we don't worry about neutrons. Or when we look at mass, we don't care about the electrons. That the ion and atom have the same mass because electrons are almost weightless. It doesn't add on to the mass. Okay, so this is a notation. All right, actually, do take note the bigger number is the mass number. All right, and also known as a nucleon because come from the word nucleus. Okay, so don't mix it up with neutron. All right, okay, and do take note this is a bit different from what you see from the periodic table. It is opposite. That means the small number, the atomic number first, then followed by the mass number. Right? But by right presentation, we should do it this way. So 6 is the proton number, which is known as the atomic number. All right, and we can see that later part, you will realize that actually proton number is something that never changed. So we can use to identify an element. Right, and we can also see that every element is represented by a capital letter. So if you see like Cl, there's only one capital letter, so it's considered one element. That's why if you see like CO versus one capital letter, this is two elements, carbon and oxygen, but this is only one, cobalt. That's why how we present small letter, capital letter is important. All right, it represents the elements. Okay, and of course, the electrons are arranged in the shelves. And just like if you want stability, you want to put your bookshelf, you will fill the lower shelf first, right? Before you go on to the next shelf. So we fill the lower shelf first, which only maximum is 2. Whatever we see there is the maximum electrons that they can be placed in. So we always put in the lower shelf first before we go to second shelf, third shelf, depending on how many electrons the element has. And normally in an atom, just like I mentioned, okay, I forgot to mention just now, proton is equal to electrons, right? If you use the atom, word atom, right, proton is equal to electron. That's why they got no charge because the protons and electrons can cancel one another since they're oppositely charged, right? Another term we move on is isotopes. So isotope basically same protons, different neutrons. So you can see that here we will say that this is carbon 12. So they use the word 12, 13, 14, right? These are all mass number, right? This help us to identify the different isotopes. So are we able to tell their isotopes on the periodic table? We will not know, right? It's fine. It's just like if you see me today, you won't know whether I have any siblings. Similarly, if I look at element in the periodic table, I will not know they have isotopes like siblings like that. But this term is help us to understand why they have different mass and why sometimes they got different size that also will make a difference to the melting point, boiling point. So we mentioned just now, same proton basically means same element, right? And you will later realize that electron is the one that determine the chemical properties, the reaction. So basically in chemistry, what we are studying is electrons. What happens in the proton neutrons is called nuclear physics. So it's where the physicists study, right? It's a nuclear reaction. It's different from chemical reaction, right? In fact, we not only about the electrons, it's about the valence electron. That means the outermost shell, right? That will determine the chemical property, which later we'll talk about it. Right? So since they got different neutron, they have different mass. So physical is something that we can measure, we can observe, right? So technically, mass is something we can measure, so it's a physical properties. That's why they got different physical properties. So scientists discover that the group 18 are considered stable. So you can check that neon is 28. Argon is 18, right? It's 288. And then helium, of course, the first one is actually 2. So scientists discover that they are stable, they don't need to bond. So they make a conclusion that right, all elements or all atoms will go through bonding or will want to make sure they are stable by achieving the stable electronic configuration. We call this a fully fused valence shell. It's considered stable. No, it's just like if you're hungry, not enough food, you don't feel good, right? But if you're too hungry or if you're too full, sorry, you also won't feel. I mean, you also won't feel so uh comfortable. So just nice. So in this case, what is nice is 8. Most of the time, the magic number is 8, unless it has only one shell, then you'll be 2 electrons. That's why we go on to understand about ions, right? Because they want to be stable. So we need to understand the big picture is everything starts from atom, right? And atom has no charge, that's why protons is equal to electrons. Okay, we can see, is it protons equal to electrons? 11, 11, that's why I got no charge, right? But when you write the electronic structure of sodium, you will see is 2, 8, 1. So you one in the outermost shell, there are two ways either to lose one or gain 7. Of course, it's easier to lose one electron. So when you lose one electron, now proton is the same, 11, but now the electron is 10, is lesser. That's why overall charge is 1 plus, because you got one more protons than electron. All right, so it's just take it that electrons are negatively charged. So if you lose your negative friends or negative habits, you become more positive. And likewise, similarly, it will happen for the non-metal. So you will see that normally metal would like to lose because if you look at periodic again, metal normally has 1, 2, or 3 valence electron. It's easier for them to lose to be stable. All right. Whereas non-metal will tend to gain. So you see fluorine, same thing, proton, electron, same. That's why no charge. All right. Then okay, the electronic structure is 2, 7. So look at the last cell, they can either gain 1 or lose 7. Of course, it's easier to gain 1. So after gaining 1 electron, now the electron is 10, proton is 9. So that's why it's negative, right? Because there's one more electron than proton. Okay, so technically we can see that, atom will either lose normally for metal or gain. Okay, normally non-metal, and then they form ion. So they become positive because proton more than electron, and then negative if we gain electron because electron more than proton. That's how they get the charge. All right, and of course we mentioned stable electronic structure means 8 electrons in the outermost shell. To be more correct, it should be 8 or 2. Right? Of course, this one is only apply if only has one shell. Then maximum is 2. Okay, so it's better to say that for to be stable, you need to have fully fused valence shell. All right. Okay, so that will be the part for atomic structure. We talk about atoms, isotopes, the term of isotopes, and then why they form ion is to be stable. So I will catch you in the next topic on chemical bonding.